So this Saturday you have quiz 1 of EIC subject, and it's for 30 minutes, 2 to 2:30. You know that October 2nd, Gandhi Jayanti, it's a public holiday, so there will not be any class, but there will be an assignment scheduled, okay, quiz scheduled from 2 to 2:30 p.m. Sorry, the class is from 4 to 5:30, then the assignment is from 4 to 4:30, okay, 4 to 4:30 p.m. So we will schedule it in Teams. You need to answer, okay. All right. So we were in the previous class, we were discussing about some of the code tuning techniques. Code tuning is used to improve the efficiency of the code, in the sense to improve the time required for the execution as well as the memory, right, to reduce the memory. So in order to improve the time and or time efficiency or time complexity and space complexity, some code tuning techniques are used, okay, generally. And the first one is jam or combining the loops. We've already discussed all these things. The second one is using the constants of correct type. When you assign the values, properly assign based on the data type of the variable. And the third one is pre-compute the result. Okay, whenever that result will be used for or used frequently in your code, better you pre-compute and store it, and the stored value can be directly used instead of computing it every time. Okay, and the fourth one we discussed is unswitching of the loops. That is nothing but dead code elimination. Okay, when you have an instruction which will not serve any purpose inside the loop, better you just move it outside the loop to improve the execution time. That is about unswitching of the loop. And the fifth technique is unrolling the loops. Okay, so we were discussing about this unrolling of the loops in the last class. So I will just give you an example so that is this covered in the last class or yet to do? Anybody remember? All right. So I will just write an example. You have a variable, say you have a variable I is equal to 1. Then I will write a loop while, okay, just a condition I less than n. Then let me write it as a of I is equal to I and I is equal to I plus 1. Can you tell me how many times this loop will execute? How many loop checks you have? You have n loop checks, right? I is initial value is 1 to n. The last condition is I less than n. So totally it is n loop checks, right? Now the same code I will rewrite while I less than n. Of course I is initialized to 1. Okay, while I is less than n, I will write a of I is equal to I. That is, ith value is directly stored in the ith index of the array. Then in the I plus 1th index, I will store the next value. Okay. Fine. So the purpose here, what we are doing is, you have an array. You start, the index is 0, 1, 2 and so on. And in the 0th index, you are storing 1. A of I is, okay, a of 0, sorry it is. So index is 1, 2, 3 and so on. So in this I will keep 1, 2, 3, 4 etc. Okay. In one iteration one value will be stored. So to keep n values in the array there will be n iterations. But here a of I is equal to I, a of I plus 1 is equal to I plus 1, then I is equal to I plus 1. Sorry, I plus 2. Okay. So what happens here is, for one iteration, I am pushing 2 values to array. Okay. This is my first iteration, index 1 and 2. For my second iteration, see, I am doing I is equal to I plus 2. So from 1, I am directly moving to 3 and I am storing the next 2 elements, because a of I is equal to I, a of I plus 1 is equal to I plus 1. So in the second iteration, I am moving the next 2 values. Then from 3 I will directly jump to 5th index and I will store next 2 elements and so on. Instead of iterating for every increased or every iteration of I am pushing 2 values at a time so that the number of loop checks will be reduced to half, right? Because loop will be iterated n by 2 times. The reason is in every iteration I am pushing 2 values. So when I have n values to be pushed into the array, I just require n by 2 iterations, right? So this is nothing but unrolling of the loops. When you have something which could be done inside a loop, just with the addition of 1 or 2 instructions, if you can improve the time and space complexity of your program, then you can do it. But make sure that it will not affect the readability or the quality of the code. Okay, this is a simple example. Of course, it reduces the time taken by the loop in the execution. This basically can be done only for the looping concepts. Okay, so unrolling of the loop. Instead of iterating for every new value of I am iterating for every alternate value of I. Okay, and this can be achieved just with the addition of one instruction, extra instruction here. Okay, that is a concept of unrolling of the loops. Fine. So number of iterations in the loop are reduced. Fine. So they have given example employee numbers to be stored in the array. Assume that these 1, 2, 3, 4 are the employee numbers, or whatever the value of I is are the employee numbers, and there are n employees in the organization. When you are storing the employee number in the array, how many iterations have to be performed? How many iterations have to be run in the loop? Okay. So in the first case, it is n loop because I am doing I is equal to I plus 1. That means for in every iteration, I am pushing one employee number to the array. But when I unroll it in the second case, in every iteration, I am pushing 2 employee numbers to the array so that the number of iterations are reduced to half. Okay, n by 2. Any doubt here? The next code tuning technique is, see, these are all the practices you can adopt in the implementation or in the design to improve the time and memory. Okay, even if you do not adopt these codes, it doesn't mean that your code is wrong, but your code is not the efficient one. Okay, so understand the difference properly. So to make the code efficient, we are using these code tuning techniques. Okay, fine. Now minimize the work performed inside the loop. Fine. So again, I will explain with the example. I think that is better for you to understand. So consider the statement I is equal to 1. Okay. While I is less than, say, x by 2. X has some value. I do not know. Then I perform some operations. Okay. So what happens in this code is every time the condition is checked, that means for every iteration of the loop, every time the condition is checked, there is an additional operation that have to be performed, right? Every time x by 2 have to be computed for every iteration. So if there are n iterations, then if there are n iterations, all the n iterations will have this x by 2 computation involved, right? So instead, if we minimize this work, say I is equal to 1, and before I start the loop, if I write n is equal to x by 2, then I can simply write the loop as while I less than n. So this reduces the time required for the computation of x by 2 inside the loop, right? I just have to compute x by 2 once outside the loop and the same value will be used directly inside the loop. Every time the loop is run, you do not have to compute x by 2. Okay. This is what is called to be minimizing the work performed inside the loop. As far as possible, try to reduce the the operations performed inside the loop. maybe in the looping condition, if you can avoid, because somewhere, for example, if this is, say, instead of x by 2, I have something called as square root of x. Okay, every time you check the condition, instead of computing the square root of x, you can directly compute it outside the loop, square root of x, and that value can be used as a variable in the condition. This reduces the time, basically not the memory. This reduces the time of computing square root of x every time the loop run. Okay, so that is the concept of minimizing the work performed inside the loop. Now use sentinels in the loop. You know that whenever you have a character array, okay, character array where I write character C of 100, okay, and say I have only 3 characters stored, then my character array will look something like this. If you remember the concept, A, B, C, and there will be a null character at the end, right? Even though the character size is declared to be 100, we do not go with all the 100 characters in the loop. We do not check all the 100 characters in the loop. We check while C of I not equal to /0. I do not know how many of you remember this concept. You check till, or if the character you have reached is a null character. Whenever you reach a null character, that is nothing but the terminating part of the string, and that is called as a sentinel. Okay, so that is called as a sentinel, and that is used to mark the end of the loop. Fine. So always it is better you have a sentinel which gives you a part to terminate the loop or the end of the loop. And when you use it, if you do not use the sentinel, of course you have to check while C of I is less than n, right? Less than n. And if the value of n is say 100, you will have to execute it 100 times. Fine. So instead of doing that, if you reach till /0, your execution time is much more reduced, right? So that is the concept of sentinel. So this is used to mark the end of the loop. Okay, fine. Now, next is reduce the strength of operations inside the loop. Reduce the strength of operations inside the loop. See, if you remember the concept of recursion which you have studied in your previous class or in your PSUC, when you have an operation called 2 plus 3, this can be performed it as 2 plus 2 plus 2, right? Multiplication is nothing but a repeated addition, or I can say addition is a cheaper operation than multiplication, and this multiplication can be represented by repeated additions. Okay, the same concept is discussed in the recursion. Some of the operations can be brought down to their basic levels. Okay, that basic level is nothing but, in general word we say it as cheaper operations. Okay, so multiplication can be replaced by addition. Similarly, I can write, say, 4 by 2, I can write it as 4 minus 2, right? So the division can be replaced by its cheaper operation called subtraction. Okay, so when this is done, okay, when a operation can be replaced by the cheaper operations, this reduces the strength of operation. Next, if there are some variables, fine, if there are some variables inside the loop which are independent of the looping variable, they are not modified with respect to the loop. Every time you run the loop, the value of those variables remain the same. Such variables can be moved outside the loop. For example, I will write a simple example. For I is equal to 1 to n, Okay, I will write it like this. Then I will write it as C of I is equal to something, okay, A into B into C. Something, some operation I will write. Okay. Instead of doing this, see here, the variable I varies from 1 to n. Only this variable changes, right? Value of A, B, C remain the same irrespective of value of I. Yeah. So in that case, this could be simply replaced. I will write it as a C of I is equal to A comma B comma C. I can write it as C of 1 also. Then somewhere down I will write the for loop for I is equal to 2 because I have already replaced 1 2 to n. Okay, I will write it as C of I is equal to C of I into C of 1. Okay, so I will use this, then I will replace this. Okay, here I can write it as C of I, that is better. Okay, or I will simply write it as I, otherwise it goes purely independent. Okay, I into A into B into C. See now here, I is a variable which is manipulated in the loop. Okay, only I is manipulated in the loop, but A, B, C are a kind of constant values which will not be modified. So in such cases, if this computation is moved somewhere outside the loop, then every time computation of A into B into C is reduced inside the loop, right? So if this is computed and stored in say C of I or C of 1 somewhere outside, then you can simply reduce that operation just with performing the remaining ones. Okay, just by performing the remaining ones. This also reduces the strength of operations inside the loop. Try to minimize the usage of the independent variables inside these examples are the dummy examples I'm giving you just for you to understand. Okay, just for you to understand the concepts. Of course, they may not have any practical implications here, but for you to understand the concept, I'm giving some dummy examples, right? So the main focus here for reducing the strength of operations inside the loop. First one is try to replace the complex operations by their cheaper variations. Okay, that is the first thing. Second thing is, if there are any independent variables in the sense independent of the looping variables, okay? If there are any such variables in the code or inside the loop, try to move them outside the loop, and of course later on again you can convert them to the cheaper versions. I think instead of this into, it should be plus. Okay, try if it is working, you will understand it better. Okay, so that is how it should be done. Okay, trying to convert them into the cheaper variations inside the loop, and whichever are independent, just moving them outside the loop. Okay, that is how we reduce the strength of operations inside the loop. Now the next one is stop testing once the result is determined. Okay, stop testing once the result is determined. So once the result is found, whenever you go with any loop, okay, say a simple example, I'll tell you, you are searching for some element. Okay, assume that all the elements in the array are unique and you are searching for say some element called 5. Okay. Whenever you find element 5, here it is there in the second position, element is directly found here. Whenever you get that element 5, you need to terminate the loop instead of going till the end of the array. Okay, so as soon as you get the result, you should stop testing or you should terminate the loop so that execution of the loop for the remaining elements will be reduced, which saves the time. Okay, so you might have some algorithms which are designed in such a way that the loop might continue even though you have found the result. Fine, so you should avoid it. For example, when I write say if a is less than 10 and say b is less than 20, then you do something. Okay, then you do something. Fine. So instead of writing this, instead of writing it in a single statement where all the two will be executed every time, I can write if I is less than 10, only then I execute B less than 10, B less than 20. Okay. So the thing is, you should stop testing this particular condition when A is not less than 10. You should not check for B less than 20 condition when this condition is false, when A less than 10 condition is false. Okay. You should have heard about the fact of short circuit evaluation in your PSUC. Okay. Short circuit evaluation. When the first condition is false, then you should not check for the second condition. That is a kind of short circuit evaluation. Okay. So short circuit evaluation should be followed when you are testing for the condition, in the sense when there are more than one condition specified in a statement or in a loop, then make sure that when one of the condition is false, you do not check the second part of it. Okay. They are called as short circuit evaluation, and that should be adopted when you are writing the program or the algorithm. Okay. Next, order tests in case statements and if else chains by frequency. Okay. So the case attempts in case of switch. Okay. In case of switch, all the case attempts you write, when you write it, you write the frequent, you remember we write the default case at the end, right? We write the default case at the end and we write say case A or case B here. Okay. But when you are writing an efficient code, you should always remember that the frequent cases should be written in the beginning. Frequent cases should be written in the beginning. If you do not write the frequent cases in the beginning, say your frequent cases you are checking for Z and you start writing from small a, small b, small c, every time it will take the comparisons, more number of comparisons. Z will be compared with A, it is false. Z will be compared with B, it is false. And how many comparisons? 26 comparisons till you reach Z, right? But when you know that Z is the most frequently used case in your program, you can simply write Z in the beginning. Second most frequent, say Y in the next, and so on. Okay. So by writing the frequently used cases in the beginning, time taken is reduced. Okay. So based on their frequency, your cases should be returned. Similarly for if else, most frequently used condition should be returned in the beginning. Otherwise, simply checking for it, even though it is not frequently used, is waste of time. Okay. So the case statements need to be arranged based on the frequency. This improves the execution time. Okay. Next. Minimize unchanging assignment operations in the loop. You have a loop, okay, say for I is equal to 2, I less than 10, I plus plus, okay. I have some statements, say A of 1 is equal to 10, okay. Then A of I, say I plus 1 is equal to I into A of 1. Some operations I am doing. Okay. Anyway, I am directly using this value here. Okay. Close. Now, when I write like this, how many ever times you execute this particular loop, this is a constant, right? Every time, okay, maybe your I is 2, then it is 2 into 10. When the value of I is 3, then it is 3 into 10, 4 into 10, and so on till you reach 9 into 10, right? This is a constant. This will never change because a of 1 is equal to 10 is initialized inside the loop. So every time when the loop runs say 8 or 9 times, all those 9 times this initialization will happen. This assignment operator will execute and 10 will be assigned to a of 1, right? So if instead of having one assignment, we are having 10 assignment operations performed inside the loop when the loop executes 10 times. So this can simply be avoided by just moving this statement outside the loop and say for I is equal to 2, I less than 10, I plus plus, I can write a of I plus 1 is equal to I into a plus 1. Instead of executing this 10 times here, it can just be executed once outside the loop and the value can be used. Okay. So unchanging assignment operators. The clause is only for the assignment operator, and if that assignment operator doesn't change the value or doesn't change the value to be given for the execution of any other instruction, then such statements have to be pushed outside the loop so that they will not be considered for the iterational execution, which saves the time. So that is another code tuning technique which is to be adopted when you have the assignment operations inside the loop. Next, reduce strength in logical and mathematical expression. The example is very clearly given to you. Okay. When you have ax cube plus bx square plus cx plus d to be performed, to be computed, then they can be replaced with their cheaper variations, which is given to you here. Okay. You should be, see, when we have that concept, when you write the algorithm, always the operations you write should be the basic ones. That means as much as possible, you should reduce the costlier operations to their cheaper versions. That is why when you have ax cube plus bx square plus cx plus d, try if you can reduce the level of complexity. So I can simply write it as ax plus b, common take it out, x plus c, another common x plus d. Okay, number of times x have to be multiplied, will be reduced, and when the computation or when the execution of such instructions reduce, of course it reduces the time. Okay, so that is the concept of reducing the strength in logical and mathematical expressions. Of course, again you need to check if you can again replace the multiplication with the addition, division with the subtraction, and so on. Okay, next, exploit algebraic operations. Identities. See, when I have a condition, for example, if square root of x is less than square root of y, okay, you have some statement, say I will write x is equal to 5, y is equal to 1, something like this. Okay. So when you are checking square root of x less than square root of y, every time this condition is checked, the square root of those values have to be computed. But can't you simply write it as if x is less than y? See, when x is less than y, definitely square root of x is less than square root of y. It's implicit, right? It is implicit. When this is true, obviously this is true. Yeah. So when x is less than y is true, then square root of x will be less than square root of y. Okay. So if you can identify or if you can represent these uh, and their complex representations can be written by their cheaper ones, then better you go with this. Okay, instead of writing square root of x less than square root of y, you can simply write if x less than y. Okay, so square root of x involves more computation and in fact it takes more time, but x less than y will take lesser time compared to square root of x less than square root of y execution. That is why when the instructions are identical, then always retain the cheaper versions, eliminating the costly operations. Okay, that is another example. Now, that is another way of code tuning. Exploit algebraic identities. Next, the last one is system routines. When you have the concept where the exact value which you obtain from the expression is not of much concern. I do not want the exact value, but based on the value returned or based on the range of value returned, I will perform some operations. So exact value is not a matter of concern. Then in such cases, you can simplify the operation by giving some approximate value. For example, log x to the base 2. Okay, the value you obtain from this is a floating point value. Okay, floating point value. And the floating point value, in the sense, you will have some integer part plus you have some floating value, right? Floating part here. Yeah. So in this execution of such statement, which gives you the accurate value, will take much more time than the result which gives you, or the expression which gives you the approximate value. Okay. Say I have 123.456, or I just have 123. Okay. This takes less time than this. Okay. So the system routine for logarithmic calculation would give a floating point accurate value, which takes more time, I can see, right? So if accuracy is not of much importance, then the approximate integer value for log x to the base 2 can be calculated, and this calculation will be faster compared to this. Okay. So inbuilt system routines need to be used properly with the caution. If you do not want the exact value, then you can go with the computation of the approximate integer equivalent or integer value, which takes less time compared to this. Okay. So sometimes we write, if you remember, if I is less than or is equal to 2, return 1, right? I do not know what exactly it returns, but I will just return some integer value just to make my system execute faster. Okay. I may not use the exact value for any other purpose. Fine. The result is not at all accurate, but the calculation is very fast. Okay. So the approximate answers can be derived faster than the accurate values. Hence, it is always better if the accuracy is not of much concern, not of much importance, then you can use the system routines or system inbuilt operations or functions to give you the approximate integer value, which can be used for later purposes. Okay. That is about the code tuning techniques which we have studied from the last class. There are basically 14 code tuning techniques to improve the performance of the algorithm. So, yeah, uh, the next part is SQL tuning. First one is code tuning. When you design or when you write the algorithm, what are the code tuning techniques you can implement? The second part of it is structured query language tuning. Fine. But this I will start in the next class. The reason is I have my vaccination due, which I have to go now. It is from 11 o'clock. So I will have to stop the class, but I thought I will finish one part of it at least. So I will stop the class for today.